Okay, hello everyone. Pasensya na late tayo sa ating live stream. Pero here we are. Kasi nagkaroon po ng mga konting technical difficulties, kaya pasensya na po. So welcome po sa HALINA'T MATH-TUTO. So our lesson today is deriving laws of exponents and multiplying and dividing polynomials. So what are we waiting for? HALINA'T MATH-TUTO. Okay, so today po, welcome again sa HALINA'T MATH-TUTO YouTube channel. Pasensya na nagkaroon po ng mga technical difficulties kanina. First time po sa ating YouTube. So welcome po sa lahat po ng students natin sa online, also modular. And shout out po sa aking mga section na hawak, section grade 7 Adelpha, Bellflower, Camia, Carnation, and Cattleya, both MDL and ODL. So today po, meron po tayong guest na teacher na magdidiscuss sa atin ngayon, and his name is Sir Jaymar Bohol. So, let us welcome Sir Jaymar.
Hello, good
Sir
afternoon.
Jaymar.
Hello, everybody. So I'm the one who will be discussing on the laws of exponent. So I'm very excited in this afternoon. How about you, Ma'am Ivy?
I'm also excited, sir, that for our students to finally meet you. Okay. So, why don't we begin our lesson now? So, i-discuss po ni Sir ay tungkol po sa laws of exponents.
So, good afternoon, everyone. By the way, I'm Sir Jaymar from Dasmariñas North National High School. From this afternoon, I'll be discussing about laws of exponent. So, I hope you'll be excited in this topic in this afternoon. So, what will be our expected lesson today? So, at the end of this lesson, you are expected to, first, you are going to derive the laws of exponent. Second, state the different laws of exponent. Then, third, simplify expression using the laws of exponent. So first, let us recall the multiplication. It is the first thing, the useful thing for the laws of exponent. So number one, so let us try to answer this. Negative 2 multiplied by negative 2. So what will be the answer? So just write down on your notebook or your sketch paper. Then number 2, negative 2 multiplied by positive 2. So what will be the result? Then again, number 3, 2 times negative 3. Then last will be negative 2 multiplied by negative 2, multiply it by negative 2. So let us see what will be the result or the answer. So let us check your answer. So from number 1, so negative 2 times negative 2, it will become 4. So negative numbers multiplied by negative, it will become positive numbers. So in number 2, negative numbers multiplied by positive, the answer is negative numbers. So negative 2 times positive 2, that will be negative 4. So next, positive number multiplied by negative number, that is, again, 2 times negative 3, that will be negative 6. So sign numbers, we just remember this because it is useful in applying the laws of exponent. And the last will be negative 2 multiplied by negative 2 times negative 2. The answer is negative 8. So when it comes to the exponent, if the exponent is odd number, or 3 times it will be multiplied from the base of -2, so the answer is negative numbers. That is why -8. So let us observe these bacteria and how these expand in every day in our life. So in day 1, just observe 2 bacteria will be expanded. This in day 2, it will become 4 bacteria. And the next succeeding days, day 3, it will become 8 bacteria. So finally in day 4, what will be, or how many bacteria will it be? So how many bacteria on the day in day 4? So try to think what will be the correct answer. So let us see. Okay, the correct answer is 16 bacteria. Why is it 16 bacteria? So the solution will show in the screen. So in day 1, it will become 2 bacteria. So in the next succeeding day, that is day 2. So 2, it 2 raised to 2, it will become 2 times 2. So it will become 4 bacteria. So the next succeeding days will be 2 raised to 3. That will become, in expanding form, it will become 2 times 2 times 2. It will become 8. So and finally, in day 4, 2 raised to 4. So 2 times. So 2 multiply it by 4 times. So the answer is positive 16. Again, how about this? Observe the expression. When you say the expression, so it talks about numbers, constant, and combination of number and constant. So how about this? Negative times 3 squared and negative 3 squared, are they equal? What are your observation of this? What is your observation? So what will be the exact value of negative number times 3 squared and negative 3 raised to 2? So let us see in the screen the solution. So it shows that negative times 3 squared, it will become negative 9. So again, when negative number multiplied by 3 raised to 2, so the negative will be remain because it is negative 1 times 3 squared. The 3 squared will be positive 9. So 9 times negative 1 will be negative 9. So the base will be 3. So how about this one? Negative 3 raised to 2. So it will become, in expanding form, negative 3 multiplied by negative 3, then it will become positive 9. So negative times negative, it will become positive 9. So are they equal? So the answer is no. So anyone who got the correct answer in the one and my students Jan. So now let's discuss what it will be the exponent. So exponent, it tells us how many times the base will be multiplied by itself. So how about the base? What will be the definition of base? So the base is the variable. It, it, it is sometimes constant or expressions in which the exponent is applied. So, okay, next. Okay, where A represent the red color of A will be the base because it will be the number how many times will be multiplied from the exponent. The n will be the exponent. So okay, next. So example, so 4 raised to 3. So 4 is the base, 3 is the exponent. So let us answer this one also. So determine the base and the exponent. So from this given problem number 1, so 5 raised to 3, what will be the base on this problem? So find the base. Anyone? Okay, the base and the exponent. So let us see afterwards. It will show on the screen the correct answer. So just think and just imagine what will be your answer. Then it will show on the screens afterwards. So the base will be 5 and the exponent will be positive 3. And then in problem number 2, the base is negative 2 and the exponent is positive 2. Why is it the negative 2 is the base? Because it is in the closed parenthesis. So negative will be included. Negative and 2. That is why negative 2 is the base. Okay, we are going to write the following in expanding form. So let us see how do you expert on this in writing the expanded form. So in number 1, 5 raised to 2. So it is in expanded form 5 times 5. So 2 times multiply the number of 5, it will become 25. Okay, try another problem. Okay, try this one. So negative 4 times b raised to 3, or negative 4 times negative 4b raised to cube, or negative 4b cubed. So how to expand this? Okay, let us see the answer on the screen. Okay, negative 4b, 3 times it will be multiplied. So negative 4b times negative 4b times negative 4b. That is the correct answer in writing the expanded form. Okay, again, from expanding form, we are going to write the another form, that is the exponential form. So reverse of the expanded form. So negative 3 multiplied by negative 3, you are going to write this in exponential form. That is, get the base negative 3 and then count how many negative 3 has shown in the screen. So 2. That is why negative 3 raised to 2. So how about this one? So try this problem. So xy multiply by xy and then multiply another one xy. So let us see what will be the correct answer of this exponential form. So you are going to apply the base. What is the base in this problem? So the base will be what? So xy. And then how many times the xy repeated? So it repeat 3 times. That is why the exponent will be 3. That is xy raised to 3, or xy cube. Okay, you are going to continue answering in the Learning Task 1, page 22 in your module. If you have a free time, you can answer Learning Task 1, page 22. So now, the laws of exponent. Let us state all the laws of the exponent. So what are the laws of the exponent? So one of these will be product rule. So what is the product rule? It is if the expressions multiply with the same base, add their exponent. So when you said product rule, you have to multiply what? You have to multiply. If they have the same base, you are going to copy the base and then add the exponent. So if this will be the multiplication or product rule, so copy the base is m, so add the exponent, that is yx plus y. So from example 1, b squared multiplied by b cubed, so the base will be b, and then you are going to add the exponent of 2 and the exponent of 3. That is why 2 plus 3, it will become 5. So b raised to 5. So you can you can solve this in another way. That is b squared times b cubed. That is b times b times parentheses b times b times b. That is, how many b are they? So they are 5 b, or b raised to 5. So again, in example number 2, so 2y multiplied by negative y cubed is equal to 2 times negative 1. So in negative y cubed, there is negative 1 as the numerical coefficient, even though there is no number you can see. So it represents negative 1. So 2 times negative 1 times y, then you are going to add the exponent of the y, that is the invincible, plus the 3, that is, it will become 4. So if there is no exponent in the variable y, it is understood to be 1. Okay. Then, okay, remember, in invincible exponent of an expression understood to be 1. So, okay, for example number 2, okay, solve the following. So x squared multiplied by x raised to 10, or x to the power of 10. So what will be the answer? So you're going to apply the product rule. You have to copy the base and then add the exponent. Okay, how about number 2? Negative y raised to 2 times 3y squared. Then the number 3, 4b raised to 4 multiplied by 3b cubed. So we can see the answer on the screen. Okay, in number 1, it will become x as your base, and then you are going to add the exponent, that is y. 2 plus 10 is, the result will be 12. So x raised to 12. You are going to add the exponent, copy the base. Again, from number 2, if negative y squared don't have the numerical coefficient, if you cannot see the number, so it represents negative 1. You're going to multiply numerical of this will be negative 1 times 3. And then from this negative y squared, they have 2 exponent. And in 3y squared, they have 2 exponents also. You're going to add that 2. So 2 plus 2, it will become 4. So negative 1 times 3, it will become negative 3y raised to 4. Negative 3 times y raised to 4. Okay, in number 3, 4b raised to 4 multiplied by 3b cubed. So here you can see the numerical number. You are going to multiply this one, 4 times 3, it will become 12. And then the variable, so you are going to add the exponent. They have the same base. So that is why 4 plus 3 is 7. So 12b raised to 7. Now, we are now in our second rule of the laws of exponent. What will be the second rule? That is the quotient rules. So quotient rules will be used in division. So when you are going to divide the power with the same base, please bear in mind you have to keep the base and subtract the exponent. For every positive integer x and y, m is not equal to 0. It should be m is not equal to 0 in the denominator because it will become undefined. So this will be the 3 laws of the quotient rule. So in each number, they have different cases. So from 1, m raised to x over m raised to y. So if your m will be x, the exponent will be x minus y, so the case will be x is greater than y. If problem number 2, if they have the same value of x and y, you are going to subtract the exponent of your numerator, that is x, and the exponent of your denominator, that is y. So m raised to x minus y equals to 1. So it will become 0. So the same number you are going to subtract, it will become 0 your exponent. Then any number that will be raised to 0 equals to 1. Then in problem number 3, m raised to x over m raised to y. If your value of your x in the numerator will be less than y, so the numerator will be 1, and then you're going to subtract the denominator from the numerator exponent. It will become y minus x. Because the denominator of the exponent, your exponent in the denominator is greater than the numerator. So next, IB. Okay, this is the example of the quotient rule. So number 1. So as you can see, a cube divide a squared. So how many times a cube will be? So expanded 3 times. So a times a times a divide. A squared will be in the denominator, it will become a times a. So you're going to cancel, or you have to cancel from numerator the value of the variable a and the denominator variable a. So all the variable that will be seen in the numerator and denominator will be cancelled. So the remaining will be numerator will be variable a, and then the denominator will be no variable. So it represents 1. So no variables or no variables will in the denominator. It will be cancelled. So 1 times 1 is 1. So a divide 1 is a. So same as a cube over a squared, it will become a 3 minus 2, your exponent will be 3 minus 2 because the greater the numerator, the greater the exponent of the numerator will be subtracted from the exponent of the denominator. So the remaining will be a raised to 1 or a. Okay, next, ma'am. Another example, number 2 in quotient rule. So if the cases will be x is greater than y again. So the same as we discussed before. So negative 2 raised to 3 and negative 2 raised to 2. So you're going to multiply negative 2 how many times? 3 times. Divide how many negative 2 multiply itself? So negative 2 2 times. So you're going to cancel all the numbers that have the same, and then the remaining will be negative 2. Then there's no number remain in negative in denominator, that is why you are going to represent it by 1. So 1 times 1 is 1. So negative 2 divide 1 is negative 2. So the same as with problem, the same as the solution, the same answer. Okay, next. Okay, the quotient rules. Okay, again, the same cases in but different examples. So 4y cubed divide 2y squared. So 4 will be factor as 2 times 2. Y cubed will be expanded to y times y divide 2 times the y squared will be expanded y times y. So cancel all the y, 2y. There are 2 y's in the denominator. You are going to cancel this in the numerator, 2y. So there is 2 in the numerator and the denominator, so you are going to cancel it and then or subtract it. So the remaining will be 2 numbers multiplied by y, that's 2y. Then there's no number or variable remaining in the denominator, that is you're going to put 1 in the denominator. So 1, because y is 1, because any number or variable has 1 on it. So 2y divide 1, that is 2y. The same with this in the same answer but different solution. So again, 4y cubed divide 2y squared. So it is 2 squared and y cubed divide 2y squared. So you're going to subtract the exponent. The same answer also. So again, in quotient rules, in example number 3. Okay, you're going to simplify this one. Okay, try in your try at home or in your sketch paper or in your notebook, try to answer the following. So 4b raised to 5 divide b. So what will be the answer for this? So what do you think will be the answer? So again, number 2 problem, y raised to 4 divide 3y squared. You are going to solve also the problem number 2. So let us see the solution on the screen. It will be shown on the screen. So 4b raised to 5 divide b. So b raised to 5. So b expanded in 5 times divide b. So you are going to cancel or reduce the b. So the remaining b will be b raised to 4 times 4 divide 1. So 4b raised to 4 divide 1, that is 4b raised to 4. In number 2, so 9 times y raised to 4 divide 3 times y squared or 3y squared. So you're going to factor 9 to be cancelled in the denominator. So we need to factor first the 9 in order to cancel 3. So to factor 9 is that will be 3 times 3. The expanded form of y raised to 4 will be y times y times y. Divide 3y squared will be expanded is y times y. So times 3 because they have 3 numbers in the denominator. So let us cancel all the 3. Numerator and denominator cancel also the y. The remaining number will be 3 and y squared because it have 2y. Then over 1 in the denominator because they have no variables and numbers remain. That is 1 has its own number. So 3y squared divided 1, that is 3y squared. So when anything except, okay, 0 exponent. So when anything except 0 is raised to 0 power, that is 1. So for example, b raised to 0 is 1. Then 2y raised to 0 equals to 1. So 2y is your base. 2y is your base. Then raised to 0, that is equivalent to 1. Then problem number 3, 10 raised to 0, that is equivalent to 1. Then the last will be, if your base is 0, it will become undefined. There's no result on this. There's no number that will become, there's no solution on this. That is why it is undefined. That is, any number or any number have the base of 0, then raised to 0, the answer is undefined. Okay, next page, ma'am IB. Okay, now we are now in the case number 2. In case number 2, the value of the exponent will be equivalent to the value of the exponent in the denominator. So your m will be m raised to x divide m raised to y. So you're going to subtract x minus y. Then the answer is 1 because there is no remaining, and there's no remaining number. It will be subtracted because they have the same exponent. So the answer will be 1. So example 1, so a squared divide a squared. So expanded a squared will be a times a divide the denominator a squared will be a times a. Then you're going to cancel numerator, variable from numerator, and then variable from the denominator, the same a. So there's no remaining variable a. That is why 1 is the answer, or 1 divided 1 is equivalent to 1. In other words, 1. So same as with this solution, same answer. A raised to 2 divide a raised to 2 equivalent equals to a squared minus a to the a to the 2, a raised to 2 minus 2, it will become a raised to 0, that is equivalent to 1. Okay, example number 2 in same exponent when x equals to y. So 5 raised to 2 divide 5 raised to 2. It will become, the expanded form of 5 squared will be 5 times 5 divide 5 squared, again, expanded will become 5 times 5. So cancel all the 5 from numerator and denominator. So there is no remaining number from numerator and denominator. So that it will become 1, divide 1, or equal to 1. So the same number, divide the same number equivalent to 1. So 5 squared divide 5 squared is equivalent to 5. 2 minus 2 is equal to 5 raised to 0 equals to 1. Why is it your 5 raised to 2 minus 2? But why is it 2 minus 2? Because they have the same exponent. So if you are going to subtract the same exponent, 2 minus 2, the result will be 0. The exponent will be 0, and then it will become 1. As shown in the rules of zero of negative exponent, zero of exponent. Okay, next, Ma'am Ivy. Okay, simplify this simplify this. If you are going to simplify it should be no negative numbers in the there is a negative exponent in the variables. So that will be the simplest form of the expression. Okay, let us answer this one. Okay, to simplify 2b raised to 5 over b raised to 5. So 2, again, b raised to 5 expanded it with b times b times b times b 5 times. Divide b raised to 5. So b represent 5 times in appearance. So you're going to cancel b, the same b in the numerator, and then the same b in the denominator. Then there is no remaining in the numerator. That is 1. And then the denominator, there's no remaining variable. That is 1. So 2 times 1 is 2. 2 divide 1, that is 2. Or in other words, 2 times 1 is 2. So in number 2, 3xy raised to 4 divide 9x and y raised to 4. So in expanded form of this, in the numerator, so 3x, so y repeated 4 times, divide 9. 9 will be factored into 3 times 3 so that you will cancel the numbers in the numerator. So to cancel the numerator, you have to bear in mind you have to find the factor of 9, that will be 3 times 3. So cancel all the 3 and all the x and all the y. So there is no remaining variable. So in numerator you have to write 1, and the denominator you have to write 3. 3 times 1. Any number or variable have 1. So 3 times 1 is 3, 1/3. So quotient rules. When dividing powers with the same base, keep the base and subtract the exponent. This will be repeating rules in quotient rules. So this problem 3 will be another case. It is x less than y, as shown before. So a squared divide a raised to 4 will be a times a will be divide a times a times a times a. It will be expanded 4 times. It repeated 4 times because of the exponent 4. A repeated 4 times. Then you are going to cancel the same variable from numerator and denominator. So the remaining will be 2a in the denominator. Then there's no number of variable in the numerator, so you have to put 1. You have to write 1. So 1 times any number or variable, that is 1. So 1 over a squared. So just same as solution, same as answer but different solution. So a squared divide a raised to 4 is equal to 1 over a 4 a raised to 4 minus 2. So again, 4 minus 2, that is 2. You are going to subtract the denominator, exponent of denominator, and numerator. So it will become 2 is the answer of the exponent. So 1 over a squared. So next, ma'am, IB. So in the quotient rule, Again, the same rules as dividing the powers of the same base. You are going to subtract the exponent. So here in example 2, cancel all the 3. So 3 cube repeated 3 times the 3. So it will become 3 times 3. So that will be the remaining. So in the numerator, there is no number will be remain. So that is, you are going to write 1 because 1 times 3 is 3. So if you are going to cancel 3, there will have always a number that is 1 that is the remaining in numerator. So 1 divide 3 times 3, it will become 1 over 9. Or another way around, so 3 over 3 cube equals to 1 over 3 raised to 3 minus 1 equal to 1 over 3 squared because 3 minus 1 equals to 2. As shown in the formula or as shown in the pattern, so if you are going to get the exponent, the denominator, so from denominator subtracted 8. So you are going to subtract the uh, exponent from numerator, from denominator, then that is the right answer. So 1 over 9. Okay, Ma'am Ivy. Okay, again, we're going to simplify this one. So in this problem, it is easy to analyze or understand if you already know the rules, the 3 kinds of rules of the law of the quotient. That is, there are 3 cases. So let us answer this. Let us think. Let us check if you got the correct answer. So in number 1, 4b raised to 5 divide 8 times b or 8b raised to 10. So from the denominator of expression, so 8 shall you have to factor 8 so that you can cancel 4. So to factor 8, it will become 4 times 2. So cancel all the 4, the same number 4, and cancel all the variable b. So there's no b remaining in the numerator, but it have 5 remaining b in denominator. So the answer is 1 over, they have 2 times b raised to 5. So 1 over 2 b raised to 5. So in number 2, same again, number 2, you are going to cancel all the same number and same variable. So cancel 5, x and y. So there will be the remaining x in the denominator, and there will be remaining also y in the denominator. So that is 3. So the answer is 1 over xy cubed. So there's no remaining in the numerator, so you may write 1 over xy cubed. So power of a power rule. So it is useful also in multiplication and division. It can also use in division. So when raising a power to power of a base, keep the base and multiply the exponent. This will be the how to get the power of power rules. So this will be the pattern. So your mx will be raised to y is equal to m times xy. So in order to get this a rule, you're going to multiply what? The power to power. So the exponent multiplied by the exponent. So from inside exponent, multiply it by the outside exponent. So a, copy the base, and then you're going to multiply the inside exponent to the outside exponent. So 2 times 3, it will become a raised to 6. Okay, how about this one? Okay, similar. They have similar problem but different solution. So they have the same answer. So a squared raised to 3. So how many times a squared being multiplied? So 3 times. So a squared times a squared times a squared. is equal to a. So you're going to add all the exponent of this variable a. So the exponent will be 2 plus 2 plus 2. It will become a raised to 6. So another example for the power of power rules. So example number 2. Okay, as you have observed in this example number 2, it is in division. It is in division category. So it has in a fraction. So a square, even though it is in the fraction, it is also it will be what? It is distributed. You will multiply the numerator, the exponent of the numerator, and the exponent of the denominator to the outside. So again, a, the numerator of the variable a will be, the exponent of a will be 2, multiply the outside 2, over b, the exponent of b will be 3 multiplied to the exponent of the outside will be 2. So it will become a raised to 4 over b raised to 6. You cannot reduce this one because a and b, they are not the same variable. So they have different variable. If they have the same variable, you can reduce. So that will be the simplest uh, answer. Okay, next. Okay, simplify this one. Okay, try this one to answer in your uh, at home today. So let me see if you got the correct answer. So try this one. So and then the result will be seen in the screen afterwards. Okay, just 1 minute. You can answer this. So b raised to 5, raised again to 2, then b, it will become b. The exponent will be 5 multiplied with the outside exponent will become 5 times 2. It will become 10. So b raised to 5 multiplied with the exponent 2, it will become 10. So b raised to 10. So exponent in the inside multiply it by the exponent of the outside. If this is if this will be the power rule. So negative 4 y raised to 4 and then raise it to 3, or you're going to how to get this one. So a negative y or negative times y raised to 4, the negative sign here, it has a number negative 1. So all the, if you cannot see the number, it is represented by negative 1. Then raised to 4, the 4 will be multiplied it by 3 in the outside, so it will become y raised to 12. So negative 1 raised to 3, it will become 3 times you're going to multiply the negative 1. So negative 1 times negative 1 times negative 1, it will become negative. So negative times y, it will become negative y raised to 12. So negative y raised to 12. Power of a product. So this are the next laws of the exponent, that is the power of a product. So to find the power of a product, you are going to find the power of each factor and then you're going to multiply the resulting powers. So have the pattern of this. Okay, you can see the m times n, they have base it with the variable x. So equal to, it shows that your m have the variable x, and it also shows that your n also have the variable x. So you're going to multiply exponent 1 times x. So if the variable m, they have no numbers in the exponent, so it is understood to be 1. So 1 times x will be x, and n 1 times x, it will become x. That is why m raised to x, n raised to x. So example 1. So 2 times ab raised to 3 is equivalent to 2, the exponent of your 2 will be 1. So 1 multiply the outside exponent, that is 3, that is 3. So 2 cube. So A, you have the 1 exponent, then multiply the 1 to 3, it will become 3. So B, it has 1 exponent, Then 1 times 3, it will become 3. So 2 cubed times a cubed times b cubed, that will be the answer. So the final answer will be 2 cubed, it will be 8. So 2 times 2 times 2, it will become 8. So 8a cubed b cubed. So this will be the simplest form. Similarly, you are going to answer 2ab raised to cube or 2ab raised to 3. 2ab, multiply it by 3 times. So 2ab multiply again by 2ab and then 2ab. So you're going to multiply 2 times 2 times 2. It will become 8. A times A times 8 will become A cubed. Then the next b times b times b, it will become b cubed. So again, they have a same answer but different solution. Another way of solving. Okay, sample number 2. Have you observed number 2? So in number 2, it's very easy. You can easily see the answer. You're going to multiply the exponent of the inside to the outside. So one by one, the variable, you are going to multiply the exponent to the outside. So 2 times 4, so 8. So x raised to 8, your y will be raised to what? So you're going to multiply 3 times 4, that is 12. So x raised to 8, y raised to 12. So you have now the answer. So it's so very easy. You have just learned the pattern in the lesson. So note, if separate by addition or subtraction, the power of product, it cannot be used. So you're going to use the FOIL method in here. So not all problem will be using by the power of product, but you are going to use the FOIL method. It is separated by addition or subtraction. For example, x squared plus 2 raised to 2 and raise again to 2 is not equal to x4 plus 2 raised to 4. The square of x squared plus 2 squared is not equal to x4 plus 2 raised to 4. Okay, the square of a times b, c raised to 7 is equivalent to what? So let us try this one. So let us try this one. So as you can observe in this expression, algebraic expression. So the variable a, it has one exponent. So the one exponent multiplied by the outside. So 1 times 2, it will become 2. So from b, the variable b, it has one exponent. So 1 times 2, again, it will become 2. Then the remaining variable c, it have 7 exponent. It have a 7 exponent, multiply it by 2, it will become 14. So the final answer will be a squared, b squared, c raised to 14. So in number 2, so 2x, so the cube of what? 2x raised to 5, y raised to 4. So what will be the cube of 2x raised to 5, y raised to 4? So let us again, as I have said already, that any number or variable, if they have no exponent, it is understood to be 1. So the 1 in the exponent of 2 multiplied by 3, in the x, your variable, the exponent will be 5, multiply it by 3, it will become 15. Then in variable y, the exponent is 4, multiplied by 3, that is 12. So 2 cube, it will be simplified. The 2 cube will be simplified or expand it to 8. It will be simplified as 8. Then x raised to 15, y raised to 12. This will be the simplest form or the answer. So again ma'am.
Hi, sir. Okay. So, interrupt ko lang po si sir kasi time na rin po. Pasensya
Time is
na.
already time. So
Opo.
again,
Kasi po,
because the
may
lesson is so
klase.
very
Mhm.
long,
Mhm.
we can finish this today. Okay.
Mhm.
What's your
Opo.
Do you have any Anything to say about them, Ma'am Ivy?
Yes po, kasi po it's already time
It's already
for their
time.
ESP class. Opo, online na po nila sa ESP at 1:15. So interrupt ko na lang po muna ang klase ni Sir. So thank you so much, Sir Buhol. Thank you so much po sa ating uh, guest na teacher. Yan. So hopefully, lahat po tayo ay may natutunan. Ang na-discuss po ni Sir is about the laws of exponents. Actually, in the laws of exponents, you can apply these in the multiplication and division of polynomials. So if you know the laws of exponent, it is easy for you to multiply and divide the polynomials. Okay po? So, sa mga ating sa mga students po natin sa online, please answer your learning task in lesson 5. And also sa mga modular students natin, week 5 po ang sasagutan nyo, yung mga learning task po doon. So, once again, thank you po again, Sir Bohol, for giving us your time in discussing lesson 5 or week 5 of laws of exponents and multiplying and dividing polynomials. So, may
Okay,
sasabihin
thank you
po
again,
ba tayo,
Ma'am
Sir?
Ivy. Okay, thank you again for
Okay.
watching in my discussion of the laws of exponent. Okay, see you next time. Okay,
Opo. Okay,
bye-bye.
see you everyone. See you next time.
Okay, see you
Goodbye.
everyone. Thank you.